Hey guys, this video lesson is going over cross sections, the notes, so please have this open so you can be following along with me. Alright, so this first slide kind of just talks about what a cross section actually is. So a cross section is the 2D, so fill that in, 2D shape that results from slicing or cutting a 3D figure. So either one, from cutting it or slicing it. So if you take a look on the right hand side, I gave two examples. So on the top, here is my cross section. This is being cut parallel to the base, and we'll talk about what that means in just a moment. And then on the other side, this one is being cut perpendicular to the base right there. So when a 3D shape is cut or sliced, you're going to actually get a different shape. But that would be a 2D shape. So kind of remember what we talked about last Friday. We talked about 3D shapes and two-dimensional shapes. So 3D figures are your cubes, your rectangular prisms, your triangular pyramids, all of those. And then a 2D shape is triangle, rectangle, square. So you're cutting a 3D figure and getting a 2D shape. And then cross sections can be created by a parallel cut to the base or a perpendicular. That one's not going to fit in there. Cut to the base. So if you take a look at the other two examples I put on the same slide, notice I have a cone and a cylinder. Right here, this would be parallel to the base. So our base of a cylinder is a circle right there. So if you're cutting it parallel, that means those two lines will never intersect, right? You're cutting it by a line that will never intersect the base. Then if you take a look at that example as well, notice they also cut it perpendicular to the base, so that's an intersecting line with the base of that shape. So either one is still creating a cross section. We also will be taking a look at a few cross sections that will be cut diagonal to the base. So that would be going across like that. We'll talk about all three of those in the lesson as we continue. So a few more definitions here. When we are slicing our 3D shape, if we make a parallel cut to the base, so when you slice a 3D shape parallel to the base, the 2D shape that you form will be the same shape as the base. So when you cut something that is parallel to the base, take a look at my two examples. I have a cylinder and I have a rectangular prism. Notice they are creating that cross section. They split it parallel to the base, and the 2D shape that you formed is the same shape as the base. So in a cylinder, our base here was a circle. So the cross section it created when I cut it parallel to the base was a circle. Same idea for your rectangular prism. The base on a rectangular prism is a rectangle. Okay, so the cross section when I split this parallel to the base will be the 2D figure of rectangle. Then perpendicular cut to the base. So when you slice a 3D shape perpendicular, the shape formed will be the same as the sides. So we have two examples again. Here's a rectangular prism and a rectangular pyramid. Notice they're slicing the shape perpendicular to the base, so it's going straight up and down here. And as you can see on this rectangular prism, my sides are rectangles, so my cross section is a rectangle as well. And then on a rectangular pyramid, this one might make more sense. My base was a rectangle, but my sides are all triangles. So when I slice a 3D shape perpendicular to the base, my cross section is the same shape as the sides. So my sides are triangles, that means my cross section here should be a triangle. The rest of the slides are practice. We should be using that website that is linked in your slides as well to help you figure out the cross sections for each 3D shape.